So in this section, we are going to talk about geometry applications, which mostly means word problems. And we're going to talk about those word problems with the topic of circles and irregular figures. Okay, so whenever we talk about a circle, we're talking about a two-dimensional. It's not 3D, so it's not a ball or a sphere. It is strictly two-dimensional, so it's a flat surface and it is a true circle. So we have several things that we need to identify first. Let's talk about the radius. Now the radius is only half of the width, so it's from the dead center of the circle to the edge of the circle, and that is your radius. And so you have a radius there. You've got a gazillion radiuses or radii on here. Okay, and so we're just showing you this radius here and this radius here, which, by the way, all the way across going through the center of the circle, that's called the diameter. So what you need to remember here is that half of the diameter is the radius, okay? Because remember, the diameter is all the way across through the center of the circle. All right, so that is one way to write it, or you could say 2 times your radius is your diameter. Those are the same thing. These guys are the exact same thing, okay? So now we're going to talk about two different properties. Now with shapes that have a vertex, we talk about the perimeter. But whenever you're dealing with a circle, you don't have a vertex. And so we're talking about the perimeter in terms of the circumference. So the circumference is the perimeter of a circle, okay? And there's a formula for that. So the circumference is equal to 2 times pi times r. And just so you know, we are going to be using pi to, and notice I use squiggly equal signs there. That means I'm approximating pi. We're going to be using 3.14 for pi. Pi does continue on past that 4, but we're just going to round it to 3.14. But if you're going to work for NASA, don't round it at the 4, okay? You just need to probably use the pi symbol. But for this class only, because we're not going to the moon, we're rounding it at the 4 on the 3.14. All right, so then the area of the circle is pi 3.14 times your radius squared. So you have to raise your radius to the second power and then multiply times pi. Okay, on this example, we have a circular sandbox that has a radius of 2.5 or 2.5 feet. Find the circumference and the area of the sandbox. So the circumference, like we learned from the previous page, has a formula that is 2 pi r. And so we've got C is equal to 2 times 3.14 times 2.5. Okay, and whenever we do that on our calculator, we get, okay, so let's say that you were going to put something on the edge of that sandbox. You wouldn't want to go in there and get 15 if you were going to put rope around it or something. You wouldn't want to get 15. You'd want to get probably 16 or so. So it really depends on what you're going to do with the information. And remember, since perimeter is like a one-dimensional thing, we are calling that just plain old feet. All right, so then the question says to find the area. So area is equal to pi times radius squared. And so area is equal to 3.14 times 2.5 squared. So on my calculator, I'm doing 2.5 squared, and then I'm doing times 3.14. And I get that the area is equal to 19.625. And don't forget, our units of measure for area are square feet or feet squared. So make sure you're using the proper units of measure. So this problem, notice that it didn't say anything about where to round. So my calculator terminated after the 5. So the true answer on this problem right here was 19.625. That's what the calculator said. I didn't round that at all. So it really does depend on what the question says. Now, sometimes I'm going to ask you questions and I'm not going to tell you where to round, and I just want you to choose. So at this point, if I don't tell you where to round, if you had told me 20 for this answer because it rounds to 20 and you said square feet, I would have taken that. On this problem up here for the circumference, if you had told me 16 square, or sorry, not square feet, but just feet, I would have taken that because, again, I'm not telling you where to round. And so you need to decide what's appropriate for the problem. All right, on this problem, it says a circular table has a diameter of 4 feet. What is the circumference of the table? Well, remember, circumference, is 2 times pi times radius. But in this problem, we're not given the radius, we're given the diameter. So the diameter is 4, so that means your radius is half of that, which is 2. So in this problem, I'm going to do 2 times 3.14 times 2. And I get that the circumference is 12.56, and it says feet, so we're going to use feet there. Now, again, didn't tell you where to round. If you had told me 13, that would have rounded to 13. That's fine. If you would tell me 12.6, I would take that as well. But just round where appropriate. And whenever it doesn't say, you kind of get to be the boss of that. You get to decide what is appropriate. All right, on this problem, where it's done just a little bit different, it says find the diameter. So we're looking for the diameter of a circle with a circumference of 47.1. So again, I'm just going to rewrite the formula for the circumference. So I'm going to put in what I know. It says that the circumference is 47.1. So I'm putting 47.1 right there. And we're going to solve for r. That won't answer our question because we're asked for the diameter, but it'll at least help us get there. Okay, so on my calculator, 2 times 3.14, or you can do that in your head. And then to solve for r, I'm going to divide both sides by 6.28. Okay, so whenever I did that math, 47.1 divided by 6.28, r is equal to 7.5. Notice the question asks you for the diameter, okay? So to find the diameter, I take your radius and I multiply by 2. So I would do 2 times 7.5 is equal to my diameter. 15 is equal to my diameter. 15 what? Centimeters. So 15 centimeters is my diameter. Okay, so in the next section, we're going to be talking about irregular shaped figures. So in other words, these are going to be figures that have shapes that we don't have a formula to find that exact shape. So a lot of times what you have to do is you have to cut things down. So you might want to read through this paragraph just for a second. I'm going to give you some time to think, and then we'll talk about the irregular figures. Okay, so on this figure, there's no one real formula to come up with this. So what you have to do is you have to break it up into pieces. So you could either break it up right there, draw the line there, and then you're dealing with this rectangle and this rectangle, or you can draw it like this, and you're dealing with this rectangle and this rectangle. Okay, I kind of like the second one better. So we know that the area, let's change the colors here so that we know what we're dealing with. I'm going to change that to red. So this red rectangle right here, I know that the dimensions are 4 and 12. And so the area of that rectangle is 4 times 12. Okay, so then on this one, the black rectangle down here, now it's not 10 because keep in mind 10 is all the way across. So we know that this right here is 4, so this right here has to be 6, because remember it has to add up to be 10, okay? And by the way, this is a 2, for whatever reason that didn't print very well. Okay, so we've got the dimensions of this black rectangle as 6 and 2, so the area of that one is 6 times 2. Doing the multiplication, And then you add those areas together. And so whenever we do that math, we get that we have 60 units squared. We don't know the units. We're just going to call it units. We don't know if it's centimeters, inches, or meters, or feet. So we're just going to call it units. Okay? All right. And don't forget square units on area. I feel like this one's pretty obvious where we need to make the cut or where we need to cut these apart. And so we're going to do a line right there. I'm going to blow this up just a little bit. Okay, so we're going to cut that right there. But I know that this entire distance is 8. And so from here to here is 5. So this has to be 3 right here. So this distance is 3. All right, so, but the thing is, that height right there, if this whole thing is 7, then and this piece is 4, this has to be 3 right here. So the dimensions of this triangle, the base is 3 and the height is 3. So remember, to find the area of a triangle, it's 1/2 your base times your height. Okay? So then whenever we do that math, 3 times 3 is 9, half of 9 is 4.5. And so then I'm also going to do the area of this rectangle. We'll do the rectangle in green. Okay, and so the dimensions of the rectangle are 4 and 8. Okay, and so then the area of the whole figure is 4.5 plus 32, which is 36.5 square units. Okay, on this one we have a high school track shaped like a rectangle with a semicircle, which is half of a circle on each end. So keep in mind this semicircle plus this semicircle makes an entire whole circle. So we can find the area of that circle, and that's going to be part of it. And then we have to find the area of the rectangle, okay? All right, so let's do this. Let's find the area of the circle first. So remember, the area of a circle, and the circle, whenever you draw a figure of a circle, you do a circle with a dot in the middle. That tells you the center. And so that's pi r squared. But we aren't given the radius, we're given the diameter, which is 68. So half of that, half of the diameter, is 34. So pi times 34 squared. Okay, so on my calculator, I'm going to do 34 squared times 3.14. And I get the area of the circle is 3,629.84, what are we dealing with, meters? Square meters. Okay, so now let's do the area of the rectangle. So the area of the rectangle is 105 times 68. So I get 7,140. So the area of the whole figure is 29.84 plus 7,140, which is 10,769.84 square meters for the area of the whole figure. Okay, on this problem, we're going to find the area of the blue region only, but keep in mind that this end has a semicircle right here. So what I'm going to do is I'm actually going to subtract off half of the circle. So I'm going to find the area of the rectangle. That's a terrible rectangle, but area of a rectangle. And I'm going to subtract off half of the area of a circle. Okay? And that'll give me the area of this blue region right here. Okay? All right, so let's find the area of the rectangle first. So the area of the rectangle is 9 times 15, which is 135 square units, because we don't know the units. The area of the circle, don't forget I want to take this and divide it by 2, is 3.14 times, and they give us the diameter, so I need the radius, and then I want that whole thing divided by 2 because I only want half of that circle. So I would do 4.5 squared times 3.14, get that answer, and I'm going to divide by 2. Notice I wrote down all of the decimal places. You don't really want to round till the very end, so write down all of your decimal places and then round at the very end if you need to. Okay, so then the area of the whole figure is 135 minus 31.7925. Which is, and I'm going to approximate this because I'm not going to write all of the decimal places, approximately 103 square units. Okay, on this problem, notice that we have a semicircle on the top. Looks kind of like a snow cone. So that's half of a circle, but then we have a trapezoid for the base. Okay, and remember this is parallel to this. And so, do you remember how to find the area of the trapezoid? Okay, so to find the area of the trapezoid, it is 1/2 times your height times your bases added together. So the area of this trapezoid is 1/2. Our height is 6.5. Our bases are 3.3 and 5.2. So on my calculator, I'm going to add this first because remember we have to follow order of operations. 3.3 plus 5.2, 8.5. So 1/2 times 6.5 times 8.5. Now I'm going to multiply these together just for the sake of ease and then divide by 2. That's what multiplying by 1/2 is. And I get that the area of the trapezoid piece is 27.625. Now I want to find the area of the semicircle. So I want to do pi r squared. Notice I'm not given the radius, I'm given the diameter. So I'm going to do 5.2 divided by 2 to get my radius. So I'm going to do 2.6 squared. But don't forget, to find the area, it's only a semicircle, so don't forget I want to divide everything by 2 at the very end. Okay, so 2.6 times 2.6, which is 2.6 squared, times 3.14. I'm going to get that answer, which is 21.2264, and I'm going to divide by 2. So the area of the semicircle is 10.6132. Now, to get the area of the whole figure, I have to add this to this. And I get 38.2, I'll just leave it at 38.2 units squared. So I did round, so I should probably use squigglies there. All right, that's it for this lesson.